Try to pay attention for at least 15 minutes before you. Hello and welcome back to Calculus2. We are continuing our exploration of... Yeah, I didn't connect to projector. I see. It's distractions. Anyway, our exploration of what? The integration by parts. So, part 1, basic idea, talked about the basic formula for integration by parts, well, the formula for integration by parts. We also said integration by parts is the backwards product rule. So the formula is integral of u dv is equal to uv minus integral of v du. That's the formula we are using. The integral on the left is the hard integral that we don't know how to solve, right? So we have this method. And then the right-hand side is hopefully something that we can do. And we did examples last time. So what's left to do today? Well, today we need to talk about definite integrals, and we also need to talk about this case over here that is a little bit on the spicier side.
It's light. It's light. If I can get it right, can I bargain with someone like 5 points from their exam?
So let's talk about definite integral. When you are when you see the definite integral for the first time, which is in Calculus 1, hopefully you learn that definite integral is from a to b of f of x dx, where you get any antiderivative capital f of x, which is computed from a to b, and then finally we compute f of b minus f of a. So this is the fundamental theorem of calculus part 1, and it is the way to compute the definite integral. Please note that you have all x variables. You have x over here, x over here, x over here, and dx at the end. So all of these are x values, and they all match. If I am to use u substitution, right, I would have to change these values all into u. If I'm using integration by parts, our values, unless we have to use u sub later, will remain x values. So we are temporarily using u and v just inside the formula, but we are not switching the domain into u or v domain. So we don't have to switch the limits. Let's take a look at Hold on. Before we do any of this stuff, I'm going to erase this and go back. I forgot to talk about ln. Sheesh. What is the integral of ln x dx? You see, that's not a basic integral. And the only way this can be done is integration by parts.
I can still do that with those.
You can do it?
Yeah.
What's u, what's dv?
U is ln x, dv is dx.
U is ln x, and then dv is?
Dx.
Dx. So what is du?
Du is 1 over x.
Okay. And
v is x.
Okay.
When you set it up, it'll be like x. It'll be ln x. Yeah, that x ln x equals or minus, my fault.
Is he right? Should we be writing it?
Yeah. Yes. Integral of x over x, which is 1.
oh, I forgot the dx.
Oh.
Yeah, which will be 1. Which will be x. So ln x minus x is the answer. Let's see.
Nice.
What happens when you come in the morning?
So we have x ln x minus x plus c, and if you want to be fancy, you can factor out x and just get ln x minus 1 plus c. So as you can see, integral of ln x is not trivial, right? Good. Now I'm going to modify this a little bit and say, what is the integral of x ln x dx? What now? U equals
ln x.
Okay.
Okay. So du equals 1 over x dx.
No. dv, not du.
You wrote du, so I was giving you du.
Oh, dv.
Oh, dv will be x.
dx, right?
Yeah.
So what's du?
1 over x dx.
And v?
V equals, what is that? Yeah, that.
Nice. All right, let's see what you get.
You ready? Oh, it's not good.
Yeah. As Nike would say, just do it.
Well, minus 5 x squared.
Good effort.
Got it.
Okay, so this will be x squared over 2 ln x minus 1/2 integral of x dx, right? So one of the x's will cancel. So I have 1/2 x squared ln x minus 1/4 x squared plus c. Again, if you want to be cool, you factor out 1/2 x squared, and what's left is ln x minus 1/2 plus c. Those are all different ways to present the answer. So now, let's go and do definite integral. So definite integral done by integration by parts. Here's problem 32. Since you already know how to deal with the ln, try this one on your own, and then when you are done with integrating all the way through, then you use 1 and e.
Okay.
Go.
For the inside, like, I can write the regular formula is u v minus integral d or v du, right? Show me.
Zero, I always put.
I think I did this wrong.
So what's u?
U is ln 2x.
And what's dv?
dv is the only thing left.
Which is dx.
Yeah.
And what's du?
1 over 2x. No.
It's 1 over x. Because the derivative of ln x will be 2x on the bottom, the derivative of 2x is 2, and 2 cancels, so it's 1 over x. Another way to do that derivative is to realize that ln of 2x can be written as ln 2 plus ln x, and the derivative of that one is 0, so just ln x. Either way. And what's the v?
X. Yes. No. X.
Just it. Put my arrow. So now what I have x ln 2x minus the integral of x dx. So the limits are 1 to e, yes. So I have x ln 2x, sorry, x ln 2x minus x, everything computed from 1 to e. Alright, so what I have e ln 2e minus e, and then minus 1 times ln of 2 plus 1. So ln of 2e. How much is ln of 2e? Well, as I said, this is ln 2 plus ln e, then minus e, minus ln 2 plus 1. So this is, ln e is 1. So I have e ln 2 plus e minus ln 2 plus 1. These two drop. Factor out ln 2. So ln 2 e minus 1 plus 1. Now this is exact answer. You can go and get your decimals if you are interested in decimals.
How do you put the make the limits like apply to the x ln of 2x if it's here only integrating the dx?
The limits have to be applied to everything because but the whole thing, it doesn't matter. The whole thing is equal to the integral, right? The entire thing is on the right, so you apply limits to everything that you get on the other side.
You don't have to re-input the 1 and the e back into the like you do for the other indefinite.
Where?
Now, for other definite integrals, you want to change the 1 and the limit, like the limits, so that
That's only if you have to use u sub. That's what I was talking about.
So what is it?
So
you don't need to do
About part.
yeah.
You don't need to do that for.
Because you're constantly staying in the x domain. You never switch domain. It's always x, 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 x. Right?
Yeah.
Right. So I think we did everything, and now is the time for the evil one.
I gotta read.
Integral of e to the x cosine x dx.
That's easy. Can I do it for 5 extra credit points on my exam?
Love the enthusiasm. There's
What
no
I wrote
extra
on the board,
points.
man.
I have respect for you, so no point.
Can you not respect me then?
Is that a challenge? Is that a plea?
I don't know what it is.
So, what do we have? In this particular problem, we have two transcendental functions, e to the x and cosine x. They're multiplied. So if you have two functions that multiply, you want to think about integration by parts. Now, in the past, other than for ln, we always use the polynomial part to be our u, because eventually, through differentiation, it will go away and make the problem easier. Now, when we had ln floating around, we put the ln for the derivative and left the x on the other part, and we were again able to solve the problem. Well, now, no matter which one you pick as u or dv, as you keep differentiating and integrating, nothing goes away. So this is one of those problems that if you analyze and you actually don't try it, you might say, well, this is the wrong way to do it. But it's not. This is the right way to do it, except we'll have to do some work. So when I do integration by parts, e to the x will go into the derivative part, it will remain the same, and then cosine will switch into a sine through integral, and then, well, let's see what we get. So
We get, can you out the answer?
You can shout out the answer.
E to the x cosine x plus e to the x sine x over 2.
Uh-huh.
Hey.
What happened with plus c?
Plus c. Hey. Just minus 1 is alright. I survived. The quiz will make it up.
So I have cosine x
You want me to do
dx.
algebra?
So du is equal to e to the x dx, and v is equal to sine x. So now,
Doesn't v equal negative sine x?
no, integral of cosine is positive sine.
Wow.
We have it.
So how to do it right?
So e to the x sine x minus the integral of e to the x sine x dx. It didn't work. Generally, we would like to see the problem improve. We would like to see polynomial piece gone, or we would like to see some different form. We haven't made a lot of progress here. Because e to the x is still there, and a
again.
trig function.
Do it again.
Exactly. What's the definition of insanity?
Something-
Doing the same thing over and over again, expecting a different outcome. All right, let's go. Be insane.
You're just gonna get a negative.
Do it again.
Need.
It's exactly what we need.
Where you already have 4 prime.
No,
we
yeah.
got this.
You got this, bro. You on the right path.
So now we have e to the x, and then we have dv is equal to sine x dx. The derivative of this one du, so is e to the x dx, and v is negative sine x. And now we set up our integral formula again. Don't forget to copy the part that is already done.
So what? You have dv sine. There you go. I was about to say,
What is the problem? Minus, and now we have minus and minus gives us plus e to the x cosine x, and now minus and minus gives us
Minus. The integral. So minus the integral.
so yeah, but
That's good.
is that's a triple negative there. So minus integral of e to the x cosine x dx.
And then
All right, so here is what we have. We came back to the same point we left off,
no, we didn't.
right?
No, we didn't.
The original integral and this piece are the same.
No, they're not.
What do you mean?
The sign is different.
Well, yeah.
So now we can add it to
Yes.
the other side of the. Oh.
Where did the other negative go?
What other negative?
Uh,
There is a negative
It's
from the
minus
function.
well, I know.
There is a negative from here, and there is negative in the formula. So that's 3 negatives. So negative.
I know there's a negative outside of the integral. There's another negative makes it positive, and you pull the negative out. Got it. I got it. Yeah.
Right? So we have 3 negative signs there.
Mm-hmm.
There is a negative sign from the integral from the beginning of the problem, right?
Mm-hmm.
There is a negative here, and then there is also negative from when you subtract
I hope this is the exam question.
in the formula. All right. Hopefully, so what I'm going to do now, it's going to look like magic, but it's not magic.
We're just gonna add.
Which way would you solve a problem like this? What would you do? You would take, right, if you have a problem which says x equals 3 minus x. How do you solve this problem?
Add x.
You add x to both sides. So this x over here, you will add x to both sides, and you will have 2x equals 3, and then you divide by 2, and x is equal to 3 halves.
Right.
So that's exactly what we are going to do now.
So we add.
See, this thing over here, you can treat as x, and here's the same x over there, and the whole thing over here is a 3. And you have a minus.
So now you divide by 2. Now it's
So what I'm going to do is I'm going to, because this first expression is equal to the one on the bottom, right? So what I'm going to do is I'm going to move this to the left-hand side of the equation. Practically, I am adding that integral to both sides, which is going to create 2 of them. So 2 integral of e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine x.
Divided by 2.
Divide both sides by 2.
You did it before. You got to the cave.
You're only adding 1.
Listen, bro. I have work before I come here, so.
Why don't you add 2 if you want?
I work from the morning. Like, I work early.
So,
I've done it.
please pay attention to what happened. First off, note that there is no negative sign over here. There's no equal sign over here because we are starting the new line. So everything that we see before, all of this part of the problem is all in line. You have equal, that connects into equal, that connects into equal, that connects into equal. So this is like one line, one long line. But when you get to this step here, this is a new line that has no equal. So it's like a new paragraph. Now, what happened here? As I said, solve this equation in your head, right, by adding x to both sides to get 3 alone, and x is on a pile, and then you divide by 2 to get x alone. Your job is to integrate this. That acts, right? Your job is to integrate it, and that acts as x in the blue equation, right? So this over here is x. Call that x. That's this x.
Krillin taught me well.
And that is equal to the whole thing over here is 3 minus another x. So what I do is I add this x, which is the integral. I add this to the other side and become 2 of these integrals, right? That's like adding x plus x is 2x. Integral plus integral is the 2 integrals if they're the same integrals. So that's what happened.
So I got it right.
It does.
So 5 extra credit on the exam?
Even thought.
No.
Wow.
So now, when you add this integral to the left-hand side, you end up with 2 of those integrals, just like you had the 2x over there. So there they are, 2 of those. And then equals to whatever the leftover is, which was equivalent to our 3 in the blue example. And then you divide both sides by 2, and you have the solution for the problem. So e to the x cosine x dx is equal to e to the x sine x. So now what
Plus
you can...
C minus 1.
We are not done. I'll put plus c over here. So the next line, we're just going to factor what we can and be done. So integral e to the x cosine x dx is equal to e to the x over 2, in parentheses, sine x plus cosine x, and then plus c, and that would be
So if
the end.
I got that line, would you put minus anything, the one above it?
No, it's fine. There we go. So you had the question?
Yeah, so is this like an isolated case, or
Yes.
is it it's not like a common
No.
problem where you're gonna solve this way?
So you have e to the x times sine x and e to the x times cosine x.
Oh, that's spicy damn. Hot and spicy. 2 equals 1. You could have just failed me. I would have been quiet as hell.
Got you there.
You're giving them ideas.
I got 3.5 weeks.
Chill.
Uh-huh.
That's all
Okay.
you got.
Bro, you didn't go down.
When are we getting from? Do it. Yeah, tomorrow.
This week. All right.
Wow. Damn.
So, I heard you want to practice this. Great. Here we go.
Gosh darn it. If it has an H, I don't know what to do with it. Move, please. Thank you. Got it. Yeah.
That's next. One week. your house.
You don't want to play the game.
What's integral of...
Wait. Just wait. Just wait, hold up. Gosh darn it. Alright, now we good.
I'll send you.
Now we good. Go ahead. Go ahead. What's the what of what?
What's the integral of sine hyperbolic?
Cosine hyperbolic.
Easy, right?
What's the derivative?
What's the derivative of sine hyperbolic?
Cosine hyperbolic.
Cosine hyperbolic. No minus signs, right?
I just said that.
You did.
Oh, what's the integral? So I'm right. So wait. I don't know. I'm getting lost, bro.
Right. So now,
Don't judge me, bro.
do we use?
It's not mine, bro. I have a black pen.
We have.
U equals.
We have integral of e to the x, and then sine hyperbolic can be e to the x minus e to the minus x over 2
So I did this wrong.
dx. And there's no need for
Anything.
integration by parts here. Can you do it with integration by parts? Sure. The same way you can come from your house here through Lincoln Tunnel. I mean, it's available.
What if that's how people actually get home? Nah, I'm not saying.
That's a long drive.
Yo, it's worth it to be in here in this class.
Shut your
That's the points right there.
I want the hands, bro.
So now we kick 1/2 in front of the integral, that's a constant. And then I have e to the 2x minus 1 dx. And we integrate this. This is 1/2 e to the 2x over 2 minus x plus c, and we're done. So, I know, no integration by parts. Sorry to disappoint. Now, can you use integration by parts? Sure, right? You can do the integration by parts, where you have your e to the x and then sine hyperbolic x, and you just go through that. And then you do it twice, and then you bring it back to the other side and you add.
Yeah, man.
That's
I did it.
that's ton of fun, right?
I'm just scared of the reduction thing that's on 6.4. One of them.
So are we going to? So let's do one spicy example, and then switch gears to trig. I know you can't wait. So that's why this problem 36 is the trig warm-up question. Integral from 0 to 1 divided by square root of 2 of y tangent inverse of y squared dy.
Why?
Because we can. I know. So try this, and I encourage you guys to discuss this with people that you care about,
So what is
sitting
the
close.
problem? I'm confused.
Take some time, and then we'll discuss it together.
So you say over here?
I can't say it well, I said it, but like, I said it fine.
Bro, he owes me $25. Like, just put it on my tab and then subtract 25.
Well, if he gives you points instead.
We could do that. I only need 5.
We can work out a whole deal.
This has been the worst trade deal.
No.
Wow. The interval of 10 makes 1/3 of 10. The inverse. But not the inverse, the interval.
You can try substituting in, there's like you can substitute like 1 over square root of 1 squared or something. Like an integral, isn't like the derivative of 10 is like 1 over.
Yeah, it's almost like 45.
That was my plan. My plan was that I had an immediate wall on not having enough. What is it? Is it 1 over?
You don't need again. Oh, I just put the other calculator. It's 2y over y of the dy. Only for the integral of 10 minus. You were out. Yeah.
I think we were to get past that, right?
Yeah.
Wait a second.
The answer is out 2.
Yeah. Dude, big bag. Or out 1. 2 equals 1, remember?
What do you usually make u? You make u the
U?
you make like u
What?
the
What
polynomial,
did
the
you
bigger
pick
thing
for
or the
u?
smaller thing?
For the U sub.
Right, I think by
U.
parts.
Me? You, what about me? Think I'm making any more progress than you are?
Stupid ass man child.
Whoa. That's my part.
Minus
$1.
minus
True.
$1.
No, he's another top.
Are you
You're just
offended?
like him.
Are you
You're
offended?
just like
Yeah, we both got the lowest grades in class.
I mean, yeah.
Bro, don't talk to him, bro. He just graduated high school.
I know.
He knows nothing about college.
Dude,
That's
my
been
man
even legal yet.
practically years.
Allegedly. Where do I begin? What should I do first?
And u equals 10 minus 1.
Yeah, I was gonna say, what if you
Nope.
do it the other way around?
The first thing we're going to do is u substitution, but we are going to call it the x substitution because x is equal to y squared. So dx is equal to 2y dy. I don't have a 2, so we'll invent that. There we go. And now this integral is equal to 1/2 integral 2y dy, that's dx. So I have inverse tangent of y squared.
Told you.
And
Said it.
oh no, or x dx. There we go.
We both said it.
X dx, and now we have to change the limits. So when I plug in y is equal to 0, the bottom stays 0, and this becomes, I think, 1/2, right? Because you need to square it, so it becomes 1/2. Great. Now what? Can we integrate inverse tangent?
Oh, you have to.
We-
Now you use the. it's
Now we use by
equals
parts.
negative
There
1x,
we go.
and then
See?
dv is dx. Big time.
Big fact.
Now what was the inverse tangent derivative?
He knows.
It's
Like
1
that
over
was
a squared plus a squared.
1 over something.
Yes.
That's why I'm scared about the next what is it? What is
Just one of them, man.
It's
Got it.
I got nothing up here, bro. I write everything on my water bottle.
Oh yeah, why is that x?
Information on the bottom.
I was just testing to make sure that people are paying attention. I was just testing. That's it. That's all it is. Great. Now, what now?
Nothing about this is good. Except the teacher. Trying to sort it slowly. I'm trying, bro.
I feel like we're moving faster than Calc 1, but there's just so much more material that it's even more crammed.
This class?
Yeah.
Yeah.
Right?
So now, what's happening with that integral?
oh, you could use U sub on
Yes. Now we use u sub. So we started with the u sub, then we have to do integration by parts. Then see, this is what the fun problems do.
This is,
one is like, hey, what's the derivative of UDX?
are you kidding me, dude? This is fun as hell. It's just the more steps, the merrier, man.
So call it. We can't use u because we used uv for by parts. So let's go with a.
No, because
A is generally parameter. Whatever.
A and B is like the
How about W?
yeah, that works.
So W is equal to 1 plus x squared. And then dW is equal to 2x dx. And here's a 2, and here's a half in front. There we go. All right, try to finish it off from here.
I don't know what's going on. I need a steady trade.
Exactly what I saw a few months ago.
Those few months ago was like 5 days ago.
Yeah.
Yeah. Pretty scam. This is one of the classes I think they have to do.
I was thinking about doing that, but I was like, I gotta come in, I gotta like test it.
Yeah. I was thinking, I was like, yo, this is like under 55, move on. Drop the class. Did I say that? Oh, did I say that?
All right, so now we have 1/2 x tangent inverse x minus 1/2 integral of dw over w. And what is that?
Element of F.
Yes. Tangent -1.
But since it's in terms of X, you gotta plug back in the thing.
Yep. Minus 1/2 ln of w, which is 1 plus x squared. And all of this is computed from 0 to 1/2. So when I plug in 1/2, I get 1/4 tangent inverse of 1/2 minus 1/2 ln of 5/4 minus the 0, inverse tangent 0, and next that all dies. And over here I have minus and minus, which gives me plus 1/2 ln. Oh, that's a quarter.
Yeah, I think you have one more.
Of 1. Well, that's 0, so that dies. And that's the answer. 1/4 inverse tangent of 1/2 minus 1/4 ln of 5/4. Yes?
So does it not matter if you start with integration by parts or you start? Is that like the case? Because I started by doing
Did it work out?
parts, and I got the same answer. Is that always the case? Or is
No,
this
you can swap them. All right, that's that. That's integration by parts, guys. Now, it's very important to know this technique because down the line, some of you might take differential equations. And if you take differential equations, you're going to get into chapter 4, Laplace transform, and that's this, integration by parts. Yes?
The answer is just if you cross out the other one, right? That's like, okay. This is like,
Well, ln1 is 0, so that dies.
yeah, and then 0 times 3.
Yes, and 0.
Is this the most bare form of integration you can do, or is there like more like
Well, this is for calculus 1, the basic integration.
So this is the most basic.
Yeah, that's why it's called elementary. Right.
Oh, I'm a low blow. We're going junior college.
Yeah, because there is what they will stuff later on coming up in graduate school. So yeah, this is elementary mathematics. All right, good.
Talk about how he got his doctorate.